Hey, and we're back for part two. Okay, so when we left off here, we had the different data clipped out so that everything was clipped within the state of Idaho, and we had just the habitat. Sorry, not the habitat. We had the species range, and we had the vehicular accidents with moose. Again, I'm going to be proceeding with moose. I want you guys to go ahead and choose your own species, and let's go ahead and take a look at processing our data a little bit further so that we can go ahead and do our analysis. Um, Now, what I'm talking about doing a little further processing here is if we take a look at uh, got just a little bit of lag here, but that should be catching up here. Let's take a look at our table here, and we look at our attribute table here. And taking a look at the protected areas, you can see I've got a total of 1,152 different features to deal with here, and that is just way too many features for the really simple kind of question that we are asking, which is what percentage or what proportion of the vehicular strikes are happening within different ranges of protected status. So that's, for one thing, way too many features. We're going to want to go ahead and kind of dissolve those together. The other thing we're going to take a look at here is we've got just way too many attributes here. So I'm going to go ahead and I'm going to clean up this data here quite a bit just so I can get rid of some of these excess attributes because I'm not going to need them. So let's go ahead and get rid of that. And let me go ahead and turn off a few things here. So we're just looking at the data that we want to look at. And we're going to be looking at the protected area districts here. So let's go ahead and consider what we need to do in order to clean up the total number of districts here. I'm going to go ahead and I'm going to create a copy of this. I'm going to go ahead and say save the features here to a new shapefile. And I'm going to go ahead and call this new copy here because I'm going to do some editing to my features, and I'm going to go ahead and call this Idaho PD cleaned, because I'm going to go ahead and I'm going to clean out the attributes out of here. And we should end up with that. I'm going to go ahead and get rid of this layer here. I'm going to go ahead and do this from a copy because I don't want to go ahead and do a hard edit to my existing data. So let me go ahead and remove this just so I don't accidentally do something there. Go ahead and mute that. Now let's go ahead and take a look at the attribute table, and there's a couple ways that we can do this. Really the most straightforward way is I can go on into the toggle editing mode right here, and you can see I've got a little tool right here for deleting fields. We got quite a few fields in here. The one that we're primarily interested in, there's two of them here. We've got our gap status, which is right here. Okay, and then we've got a descriptive gap status. And we go ahead and let's go ahead and sort this. And if we take a look at number 4, gap status 4, this is sort of the least managed protected area here. So when we're taking a look at category 4, this is no known mandate for biodiversity protection. So this is a protected area, but not managed with a mandate for protecting biodiversity. Whereas if we look at area number 3, this is a protected area, but it is still subject to use for extractive industries or for OHV use. But it is still a protected area. We take a look at category number 2. We can see that this is managed for biodiversity, but disturbance events are suppressed. So that would be, fires are controlled and that kind of thing. Whereas if we get down to protected area number 1, disturbance events are allowed to proceed or are even mimicked. So this is an area in which they are trying to allow it to act as close as possible to a natural state. So these are all protected areas. and kind of going from in order from most protected in the number 1 status to least protected with number 4, but still protected and still managed in that case. So what we want to do is we want to go ahead and get rid of all these excess fields because it's just mucking up our analysis. We don't need all these things. So we're already in edit mode, and I'm going to go into my delete fields. I've created a copy of this, so I don't have to go ahead and worry about the fact that I'm blowing out data from my only downloaded copy. And I'm just going to go ahead and I'm going to select everything in here, and well, let's go ahead and keep the shapefile attributes here, and I want to keep my gap status and my gap status descriptive gap status. I'll go ahead and hit that, and it is just chugging away at deleting those fields, and there they go. Now I want to go ahead and save my edits and get out of here. And so now I can see I've got a much cleaner attribute table here because I've gotten rid of the unnecessary attributes that are just going to be getting in my way. Now what we're going to do is the other issue that we've got here is we've got over 1,100, almost 1,200 different features in here. That's too many. I want to break this one down to just the 4 main categories that I need, and I don't want a whole lot of replication in there. So I believe in your reading. At this point, you've already read about Dissolve, and perhaps you've worked with Dissolve a little bit in the past. And Dissolve would be great, but let's take a good look at our map here. And you can see that as we look at our features here, we've got a bunch of little island features kind of spread all over the place. And so Dissolve is really good at removing the barrier between contiguous features. So if we go ahead and take a look at this one, might have gap status 1. Oh, that one's got gap status 3. So I'm sure if I look around, I could find contiguous features that have. Okay, so there we go. So there's two with gap status 3 there. It would dissolve the boundary between those just fine. But the problem is with all these islands, we're still going to end up with multiple hundreds of different features here. Perhaps instead of 1,200, but we're still going to end up with hundreds of different features because of all the different island districts that are within here. So really what we want to do is we want to go ahead and make it so that even these islands are all part of the same feature. And this is what's referred to as a multi-point polygon feature. You can a multi-part polygon feature. Apologies. There are multi-part lines and polygons, and there are multi-point point features. So we're going to go ahead and we're going to try to get this into a multi-part polygon, which has been essentially dissolved. But instead of dissolve, the function that we're going to use here is we're going to use aggregate. And where did I see my aggregate tool? You know what? I'm forgetting. Oh, there it is under vector. No, I'm forgetting where aggregate tool is, but that's fine. I kind of know what the name of it is because I've been reading on the literature and all. And if I look, okay, it's under vector geometry. So if I go on back here, if I look under my vector geometry, there's my aggregate right there. So what I want to do is I want to aggregate my protected area districts to go ahead and create one that is aggregated and dissolved on gap status. So I've left my PAD cleaned in here, and now I'm going to go ahead and I'm going to select gap status because that's the expression it's going to go ahead and use to clean this off. If I went ahead and left that blank, it would take a look at all of those fields that I've left and try to find unique combinations of all 4 of those fields. Problem is, I've got things like shape area and shape length, which are going to be pretty much unique to each individual polygon. So I don't want to do that. So I'm going to go ahead and select which attribute I'm going to use to aggregate my data. Okay, so looking at my data aggregation, noticing one curiosity here is it's interpreting the gap status as a string rather than a number. I don't like that. I'm going to go ahead and specify that to go out as a number. And now that I'm thinking about it, I can handle generating the shape length and the shape area a little bit later. So I think I'm going to go ahead and get rid of these. I'm going to go ahead and just remove these out. Now, do pay attention. This is not actually deleting these fields from the source data. What this is doing is this is just saying that in the output, these fields are going to go into the output or not, depending on whether I just deleted those. So the ones that I just removed, I haven't deleted. I've just gone ahead and removed them from what's going to go into the output. Now I'm going to go ahead and specify the name of my output field here, and I'm going to go ahead and I'm going to say it's going to be Idaho PAD. This is my aggregated Idaho PAD. And let's go ahead and see what happens when we run this. And I have got an error here. Okay, so once again, I've got an error. And now it's giving me a complaint that feature 4 from Idaho PAD cleaned has an invalid geometry. Please fix the geometry and change the processing settings or change the processing settings to ignore invalid feature outputs. Okay, so what's going on here is if you're familiar with GIS in the ARC world, what it is that we're looking at here is something that has a bad topology. If you're not familiar in the ARC world, what it is we've got a feature in here that is sort of disobeying the rules of what a good feature geometry is. Very often this will be something like a feature that crosses over itself, or a feature that has gaps where gaps are not allowed. Rules can be established, and the system is going to check for those. And it looks like the system has found an invalid geometry here that we need to fix. This is fine. This is a good opportunity for us to kind of learn a little bit of vector data quality control. So let's go ahead and take a look at our data here. And let's find what we need to do. Is the first thing we want to do is we want to validate our vector geometry here. So I'm going to go ahead and I'm going to search for valid. Check validity. Okay, so this is all under the vector geometry here. First thing I'm going to do is I'm going to check the validity. And I'm going to do it for the cleaned because that's the one that was throwing up the errors. Let's go ahead and ignore the ring self intersections because those are something that has to do with kind of the bounding polygon of the whole thing, and that's fine. We don't need to worry about that. But then we're going to go ahead and leave this to generate these outputs here as temporary outputs. So we're going to have a valid output, an invalid output, and an error output. And you'll see what these generate in just a moment here. So let's run our validity check. And, flashing the valid output, it looks like just about everything is valid. But what do we got here? Okay. I go ahead and I right click and I say zoom to my invalid output. Oh, so here's where we got an error. And if I go ahead and I move my error output point, aha. So here is where we've got an issue, and it looks like what's going on is we have ended up with a place. Yeah, sure enough, I think what we've ended up with a place is where we've got a slight overlap in the vector geometry where it's overlapping itself. That's an invalid geometry, and we need to go ahead and allow the system to fix that. So we're going to go ahead and I'm going to get rid of these temporary layers. I don't need them anymore. I've now identified that there is a problem. So let's go ahead and remove those. And I'm going to go back under the vector geometry, and I'm going to go to fix geometries here. Okay. This is going to be a simple enough menu entry, not much to choose from. And I'm going to go ahead and I'm going to choose my PAD cleaned. And I want to go ahead and I want to save this as, so I've gone from cleaned. I'm going to say that this is Idaho PAD fixed. A new step for each step of the way. Rerun. And here's my PAD fixed. I think I'll go ahead and get rid of the clean just to avoid any confusion in the future. And let's go ahead and zoom to that layer here. Where is my layer? Zoom to layer. All right, so I want to go ahead and I want to try running my aggregate again. And I don't know if you guys have had the chance to play with this before or not, but when you're running a process over and over again, trying to debug it, instead of going ahead and finding the tool again, I can actually just look at my process history here. And I can look at the process, at the history of all the different processes I've run today. And look what I've got here. So I've got aggregate. And let's take a look. Oh, it wasn't the aggregate that I wanted to do. Yes, it was. And so I want to go ahead and I want to point this to fixed. And remove that. And remove that. And I was going to set this one to be a number. And I was setting this to stamp. So now you can see, so it's still going to go to Idago PAD aggregated. In fact, I think I want to go ahead and specify. I'm going to change that to a shapefile. So let's go ahead and do that to a shapefile. Okay. So Idaho PAD shape font aggregated. Everything is looking good here. Let's go ahead and run it. Looks like it's taking a little bit more time, and I have got another error here. Could not run that. One of them is not a number. Okay, let me go ahead and let's change my parameters here. Let's go to string. Let's just go ahead and make sure we're resetting everything. Back to how it should be. We're going to go ahead and specify that. Okay, and I'm running into an error. Let me go ahead and see what's going on here. Okay, guys, I think I'm back. I have just figured out what was going wrong there, and this was a matter of me not selecting the correct aggregate function. You can see what's going to go ahead here is it's going to dissolve these different polygons together according to the value here in gap status. But I needed to choose the aggregate function, and I just quite frankly forgot to do that part. So the aggregate function here, so what it was trying to do is it was trying to concatenate each individual value together as it joins them together. And so it was just ending up with a single string of nothing but threes because there's so many districts in there that are gap status 3. So actually what I want to do is I want to go on down here and I want to choose the first value here. A little embarrassed, but you know what? I love these mistakes because we learn a lot of lessons from making mistakes. So I'm going to go ahead and I'm going to choose the first value on each one of these. Once again, I'm going to go ahead and I'm going to specify the whole number here. And I'm going to go ahead and once again, I'm going to output my output to Idaho PAD aggregated. And let's go ahead and run it, and fingers crossed this one should be it. Running for just a moment, thinking about it. And hey, look at that. Okay, so now I've gone ahead and I've aggregated my fields, and let's take a look at my attribute table. And 1200 features becomes 4 different features. So if we go ahead and we take a look and we just go ahead and we can highlight our different attributes in our table here, and we can go ahead and say, here's our district number 1, our gap status number 1 district, our gap status number 2 district, our gap status number 3 district, and our gap status number 4 district. Oh, just a little bit up there. So so this is great. This is exactly what we're looking for. So now I've got a much simpler table to look at. Except I've got one little qualm with this data here. And the qualm with this data is it does not have a status, because what we're going to look at is what we're interested in is comparing all the different protected land statuses within the bison range. And what this is not giving us is the areas that are unprotected. So we need to get one more category in here. And I want to go ahead and cut out the areas that are protected area range, but they are not within the range of the moose habitat. So let's go ahead and uh, get our data here to be just the way we want it, so that we can go ahead and do our actual analysis. Let me go ahead and clear out my selection, because selected layers can cause problems. I'm going to go ahead and get rid of fixed, because that is a redundant layer at this point. Okay, so yeah, so here you can see is my moose range. I don't want these polygons that are within the moose range, and I also want to make sure that um, I include this area that is within the moose range, uh, that it has its a designation, a category designation, a protected area category here. So we're going to go ahead and create a new one for that. So the first thing we're going to do is let's go ahead and clip out the protected area districts that are to the range. And so the first thing I'm going to do is run clip. And I'm going to input my aggregated against moose range. And we're going to go ahead and call that Idaho PAD clipped. Okay, I'm going to run it. It's giving me a warning about spatial index not existing. That's fine. That's an issue that could be resolved, but generally just means maybe a slight slowdown in the access to the data. So we're not going to worry about that. I'm going to close this. Let me go ahead and check the attribute table just to make sure everything has come through clean. And yep, we've got our 4 statuses here. Everything seems to be working, and it has clipped out these layers that are outside of the moose range. So let's go ahead and get rid of that layer there. Or remove it. Once again, removing is just fine, because you can see that the data has not been deleted. It's still up here waiting for me if I want to go get it out of the browser here. I like to keep just the absolute minimum necessary layers within here, just to avoid any confusion, because you get too many layers in there and you kind of forget which ones are part of your analysis and all. So I've clipped this, but I do still want to go ahead and make sure that I've got a category here. Now I could go ahead and try to run merge, but the problem is it's going to go ahead and create this one feature, which is the entire moose range. That's not going to work. So really what I need to do, the first thing I need to do in order to merge these 2 layers, is I need to cut out some holes. I need to make a bit of Swiss cheese out of that moose range in the shape of the PADs. Then I can go ahead and merge the 2 layers and drop the PADs into those holes, and it's all going to kind of fit together like this. Okay, so let's go ahead and take a look at our exercise here. And what we need to do now is, instead of just running a merge or running a clip, we could try running a clip, but actually I think the one I want to use at this point now under my overlay section is I want to run difference. Okay, so clip is only going to give me the things that were that intersect. This is going to remove the things that intersect. So once again, I want to go ahead and check my difference here. And the algorithm is going to extract features from the input layer that fall outside or partially overlap features in the overlay layer. Okay, so I'm going to go ahead and choose moose range as my input layer. And I want to go ahead and choose my PAD clipped as my overlay. And let's run that. Give that a second here. All right, I paused that for a second there because, as you can see, that took 41 seconds to run. So not too bad. I just didn't want a whole lot of dead air here while the process was running. So let's go ahead and take a look at what we've got from this. So if I go ahead and turn off this and this, and there we go. So there's our difference. We can see that click on this here and let's take a look at our identify. Looks like our results here. Oh, go ahead. Sorry, I've got just a little bit of spin up issue here. What's going on here, guys? Let me pause while I get control over Q again. All right, it looks like things have just gotten a little out of hand because I accidentally dragged the selection tool across this entire window, and that kind of hung up things while it was trying to select a whole bunch of different features. But if I go ahead and identify my results here and let it think about that for just a moment. And there we go. Okay, so we can see now. I see I never did pause that recording, but so we've got basically the same kind of features here. Let me clear my selection here. Just have selections here, but I go ahead and look at my attribute table. Go. Yeah, selecting too much kind of slows everything up. Okay, and I've just realized that I am guilty of a cardinal sin in GIS, which is I have not been saving my work. Fortunately, I think I'm going to be okay. I got everything unselected here, and I think I have control over my machine. But I've just realized that I've never saved my project, and quite honestly, I would have very little sympathy for somebody else who made the same mistake. So I should definitely go ahead and slap myself on the wrist for this one, and let's go ahead and save our project here. If you have not done so, please save your work early and often, because you just don't ever want to put in an hour's worth of work and then realize that something has crashed and you've lost it all. So this is going to be my Anthill Roadkill project. Okay, so I'm back in business. Let's take a quick gander at our attribute table here. And yeah, so we can see this has only got just one feature ID code, much like the moose range. If I go ahead and take a look at the attributes of my moose range, this is all I've got. So this is really just a clip out of the moose range with the PAD clipped out of it. So now we can go ahead and we can merge these together, and it's going to go ahead and it's going to create a single layer with everything put together. So I'm going to go ahead into my, let me go ahead and hide my screen here. Let's take a look into our merged vector layers here under Vector General. Once again, if you're ever having a hard time finding these things, because there are so many tools, you can always just go ahead and you can just search for merge. And looks like we've got multiple options, but I want to look for merge vector layers. And let's go ahead and choose what our input layers are, and I'm going to go ahead and I'm going to merge together difference and ID PAD clipped. Let's see what, go ahead and say okay here. My destination CRS. Okay, so I want my destination CRS. Let's go ahead and make sure that it is in the same CRS as the Idaho PAD clipped, which if I go ahead and look at the properties here, this is in ESRI 102039. So let's see what our available projections are here. And here we go. Here's ESRI 102039. Q is providing that to you as a pull down option because it's one of the CRSs of the layers that are in the map. So it kind of gives you a shorthand of selections there. And so this is going to go ahead and be merged. So I'm going to go ahead and call this one. I'm going to save this to a file. So many different versions of this, and we'll call this one Idaho PAD merged. Now let's take a look at what we get. Might take just a second here. Nope, that wasn't so bad. Close this off. Let's turn off difference. Clipped. And if I go ahead and look at my attribute table here, aha! So now I can see what I've got here is I've got one feature has attributes just from the moose range polygon, and so this one has got the year-round season code of 1. And then the other one, the other 4 features have null values for that, but have values for the gap status. So this is great. Now what we want to go ahead and do is just go ahead and fill in our values here. So I'm going to get us into edit mode. And let's start with filling out. So as we remember, this went from maximum protection at status 1 to minimal protection at status 4. This is going to be outside the protected status. So we'll go ahead and call this one category 5. And let's call it 5 unprotected. Okay, so I've got category 5 unprotected. I'm not going to worry right now about my layer or path, but I do want to go ahead and put in my, I want to go ahead and get rid of some of these fields here because I'm not going to need these. I have no use for the layer or path, and I have no use for the FID code or season name at this point. So let's go ahead and remove those. I'm going to save my work. And get us out of... Very good. Okay, so I now have a multi-part feature with 5 different multi-part features. As we go through and we can select, we can see these are my unprotected areas. These are my areas protected for biodiversity, no mandates for biodiversity problems, managed for multiple uses, managed for biodiversity, and managed for biodiversity with an emphasis towards natural systems. Okay, so very good. I do now need to reintroduce because a part of the question that we were going to be addressing had to do with area. So let me go ahead and clear out my selection here. And we do want to go ahead and get area back into these polygons. Let's go ahead and clear out my processing toolbox here. I'll make it so you can see what we're doing in the processing toolbox. And so in that case, what we're going to want to do is we're going to go into our vector geometry here, and we want to add vector geometry back into the table here. All right, so let's go ahead and add our vector geometry. And I've got my PAD merged. This is good. I'm going to stick with the layer CRS, which is great. And we're going to go ahead and call this one. I believe, if I'm not mistaken, this is my final version of the PAD. So I think I might go ahead and get just a little optimistic here. Call this my PAD final. Okay, and go ahead and run this. Now it's calculating the area and the perimeter of every single polygon in here. This is going to take just a second because, of course, these are multi-parts, which have a lot of little calculations to run. Looks like it's getting there. And I might pause this for just a second while this is running. Actually, I hadn't paused it for anything at all there because I hadn't realized that that just ran quite quickly. It ran it in 12 seconds, so I actually hadn't even needed to pause there. Let's go ahead and take a look at our attribute table on PAD final. And look at our attribute table, and now we have got, oh, wonderful. So we've got our gaps, our gap status, our description of our gap status. We've got area, and this is going to be in square meters. We can see the decimal point here. And then our perimeter here in meters, because that is the coordinate system that we are operating in for that unit there. So excellent. Now we can go ahead and proceed on. So I'm going to go ahead and end this video here, and we're going to go ahead into step 3, where we actually go ahead and start to answer our questions that are addressed in the problem. So join me for part 3.